is we'll start with some past paper questions TK in this class. तो हम कर ये रहे थे कि I told you that I told you that there were 3-4 methods in which you can figure out the order of the reaction. Most of the chapter is complete. There's still some small bits left, which we'll do later. The rate kya tha? It was the change that happens at a particular with respect to time. So I told you that the order of the reaction, you can figure out the order of the reaction with respect to the mechanism. If the mechanism is given, the rate only depends on the reactions or reactants that are involved in the slow step. Okay? It's not involved in the reactants that are involved in the fast step. So that was mechanism. We talked about determining the order of a reaction by looking at the half-life values. Or usme tha ke if it's zero order, that means the reactant concentration, if it decreases, it just decreases at a constant speed. The reaction does not slow down as the concentration of X decreases. If the reactant concentration decreases and the reaction slows down, it takes longer and longer time for it to happen. That is order one. Uske the half-lives are constant. And then you had order two. Order two was where if the concentration of X decreases, the rate decreases by a much bigger quantity, which is if it decreases by half, the rate will decrease by 1/4. So it takes a much longer time. In this case, the half-life doubles. Every successive half-life, it takes twice as long for the reaction reactant concentration to decrease by half in this case. Or you had then you had the third method, which was the initial rates method. And in this case, what you did was you compared experiments, and we'll do a bit of these questions, just a bit more of these. Okay, so last time kya tha, we'll try and figure out how the order of the reaction varies, and we'll do some past paper questions. So just 1 second, let me open some. As a reaction kinetics. So let's try and do this question. Okay, I've got this reaction. Okay, and I've got this reaction, and in this reaction, what's going on is that there is NH3, and this NH3 is reacting with ClO -1, right? So that indicates the rate of the reaction, it depends on these two things. It depends on the concentration of NH3, and I have no idea how it depends on that, and depends on the concentration of ClO -1, and I've at the moment no idea how it depends on that. Okay, so I don't know what the order of the reaction is. So what I'm going to do is I'm going to investigate, and I'm going to investigate how the rate varies, let's say with respect to NH3. Okay, so I want to figure out a relationship, only this relationship, that I want to figure out how does rate of the reaction, it's going to vary with NH3 concentration. So iske liye I would have to keep this other one constant. Remember, if you're trying to compare two variables, you have to keep all the other variables constant. Like if I want to investigate whether sunlight is needed for plant growth, so I want to keep all the other variables constant. I'll just change the amount of sunlight the plant is getting, and I'm going to see how the plant growth gets affected. So I have to keep all the other variables constant. Otherwise, it's not going to be a fair comparison. So in this case, I'm going to keep ClO -1 constant, and I'm going to see how varying NH3 will affect rate. So which two experiments will I compare? I'm using different concentrations of the reactants, and I'm getting different rate of reaction. तो कौन सा experiment compare करूं कि जिसके अंदर this is constant and these two are varying. Anyone, Alicia, Anna? अब्दुल्ला, उमर, शान, कोई भी कौन से दो experiments को compare करना है? अच्छा, so 2 and 3, right? So we're going to compare 2 and 3. Because if you compare 2 and 3, you'll notice that ClO minus 1, nothing happens to it. What happens to NH3's concentration? Okay, in experiment number 2, you used 0.2 mole per dm cube. In experiment number 3, you used 0.4 mole per dm cube. So double kar diya, you've doubled it. What happens to the rate of the reaction? If you look carefully, it's from 2 to 2, it goes all the way to 8. So that increases 4 times. So that means what the data is telling me is that agar isko double kiya na, if you double NH3, the rate increases 4 times. So that's a quadratic relationship. So यहाँ पे what you'll, the reason you'll write is if you compare experiments number 2 and अच्छा, if you compare experiments number 2 and 3, ठीक है, so ठीक है, order 2. So if you compare, अच्छा, if you compare experiments 2 with experiment 3, so this is exactly how you're going to write. You're going to state कि भाई इसको तो कुछ नहीं हुआ, nothing happened to it, NH3 concentration doubled, and your rate, it quadrupled or increased 4 times. So that indicates that it's order 2. That means that rate is dependent on NH3's concentration, but it's got a squared relationship. Okay, which basically implies that it is order. It's order 2 with respect to NH3. So I've figured this out. You clear it, Sarong? Is this clear to everyone? Shan, clear? Is this clear? So I'm going to try and figure out the other one now. So if I want to investigate, so I figured out that this is 2, right? So if I want to investigate the other one, that rate, how does the rate depend on ClO minus 1 concentration? So these two should vary, and I should keep NH3 constant, right? So now if I look at the table, what I'll notice is, okay, I need to keep NH3 constant, right? It should not change. But if you look over here, there is no 2 experiments where NH3 is kept constant. अगर मैं पहले दो को compare करता हूँ ना, what I'm going to see is that both of them are varying. So I will not know the rate is varying because of which one. Is the rate in experiment 1 and 2 varying because of ClO minus 1 concentration because you're doubling it? Or is it varying because you're doubling the concentration of NH3? So there's a problem, and in any of the experiments, NH3 is not kept constant in any one of them. तो ये figure out करना मुश्किल होगा कि how do you figure out the rate of the reaction with respect to ClO minus 1? अच्छा, with respect to ClO minus 1 concentration. अच्छा, so what I'm going to do is, अच्छा, ये clear है कि we have a problem over here. कि I can't really figure out the relationship between rate and ClO minus 1 in this case. For NH3, I've already figured out that it's order 2. And I don't know what is the order with respect to ClO minus 1. Okay? Is this clear that we have a problem with ClO minus 1 over here? Is this clear? Achha, so what are you going to do about this? What you're going to do is that you already have this rate equation. All I have to do is I need to get rid of the proportionality. So I'll get a k over there. Okay, I figured out what x is. That's 2. All I need to do is I need to figure out y. I need to figure out this y. So what I'm going to do is I'm going to take this equation and I'm going to plug in Now it's an incomplete equation because I don't know what y is. So I'm going to simultaneously solve it. I'm going to plug in data from experiment 1 and 2. So I'm going to plug in data from experiment number 1 and experiment number 2. Now, when I do that, first experiment number 1. Experiment number 1 where the rate is 0.256. So I'm going to plug in these values. It's 0.256, that's the rate, equals to K. So this is all the data that's coming from experiment number 2. NH3 concentration is 0.1, that's squared. And ClO minus 1 concentration is 0.2, and I don't know what the order is. So that's taken as Y. And I'm going to, at the same time, plug in data from experiment number, sorry, experiment 2, Tunita, this is experiment number 1. So I'm going to plug in data from experiment number 2, which is the rate is 2.05, and that's K times concentration of NH3, that's squared, that's 0.2 squared. And the concentration of ClO minus 1, that's 0.4. And I don't know what the order is. So I've got two equations. I'm going to simultaneously solve them, and I'm going to solve them specifically for getting this value of y. So how would I do that? What I'm going to do is I've got two unknowns. I've got k and I've got y. I've got k over here and I've got y over here. So k is a constant. So k has the same value in both cases. Y has the same value in both cases because y is the order of the reaction, right? So what I can do is I can rearrange this and I can measure the value of k, which is going to come out to be 0.256. And the whole thing gets divided by 0.1 squared and 0.2 to the power y. I'm going to take this k and I'm going to substitute this k in this other equation. Okay, so I'm going to put k over here. So what I'm going to have is 2.05 is equal to k. I'm going to take this k now, which is 0.256. And at the bottom, it's 0.1 squared and 0.2 to the power. Or if you multiply this, so it's being multiplied by 0.2 squared and 0.4 to the power y. And I'm going to try and solve this. Okay, it's a simple substitution method. Take the k from one equation, put it in the other one. And so if I try to solve this, so on this side, I'm going to have 0.4 over 0.2 y. And on the other side, I'm going to have 2.05 into 0.1 squared. Can you even do the math? Divided by 0.256. Up here, multiplied by 0.2 squared. What do we get on both sides? The left side. किसी ने किया कि क्या बन रहा है? अच्छा कितना है? That's I'm getting exactly 3. Sorry, I'm getting exactly 2. I'm getting 2 on this side and I got 2y on this side. इसको देखो ये, this will come out to be exactly 2. And if I'm getting 2, so that means my equation now is 2 is equal to 2y. So that automatically means y has a power of 1. Okay, so I've been able to figure out what y is simultaneously. So you could have done the same thing in the first. So all you need to do is you can actually solve this simultaneously as well, but you should only do that if agar ye wala scenario. Okay, I wanted to investigate rate with respect to CLO minus one, but I wanted to keep NST constant. But there were no experiments where NST was actually being constant. So what I did was, okay, I put in data for experiment one, put in data from experiment number two, and then solved them simultaneously. Took the K from one equation, put it in the other one, and then when I solved it, I found out that it simplifies to 2 is equal to 2y, right? So that's the 2 ki kya power hoga to get equal to 2, that's going to be 1. Is this question clear? ये clear है कि नहीं है clear? Anna, Risha, is this clear? Azim, Shan, बाकियों clear है? So finally he's asking for the rate equation. So rate is equal to k. We figured out the order. So it's with respect to 0 minus 1, it's 1. And with respect to NST, it's squared. The next part is he's asking you to calculate k. So what I'm going to do is and use experiment 1 results. So all you have to do is plug in the data from experiment 1. So k data, that's experiment number 1, that's 0.256, that's the rate. I don't know what k is. CLO minus 1 concentration, that's for experiment 1, that's 0.2. और अगला क्या, that's NST concentration, that's 0.1. और इसको solve करोगे, you'll find the value of k, which will come out to be what? It's going to come out to be 0.256. And then the whole thing gets divided by 0.2 times 0.1 squared. So I'm getting 128. And they're asking for the units of k as well. So how do you find units? You use the same equation and you'll plug in the units. The units are already given away here. It's mole per dm cube, mole per dm cube, mole per dm cube per second. That's change in concentration with respect to time. So it's mole per dm cube per second. So इसी के the unit निकालो. So you'll do rate is mole per dm cube. I'm going to take mole per dm cube as x is equal to k times CLO minus 1 concentration, that's mole per dm cube, into NST concentration squared, that's mole per dm cube. So one of the x will get cancelled out, the other x goes to the other side, so that's x minus 1. So k equals x minus 1, s minus 1. What was x? X was mole per dm cube, so it's mole minus 1, dm3, and s minus 1. He can clear us our question. Remember, every time they make the rate equation, once you get the rate equation, once you get the values of x and y, they'll ask you to calculate the value of k. So you can just plug in data from one of the equations and you'll get it. सही है, clear है? अच्छा, now अभी सिर्फ ये टेबल वाला, ठीक है? We'll just do table questions. अच्छा, this one is kind of similar. I mean, although this is worked out, so let's skip this one. Do someone that's जहाँ पे डेटा नहीं. अच्छा, एक और टेबल आया. So now in this one, it's easy. You've got two reactants, right? So that means rate depends on these two reactions. We don't know how it depends on that. So its rate is dependent on NO concentration, X, and it's dependent on O2 concentration, and that's power X as well, or power Y. So if I want to investigate rate and NO, I'm going to keep O2 constant. So for this, I'm going to keep O2 constant. So I'll use experiment number 2 and experiment number 3. You get 2 and 3. Double. What happens to the rate 4 times? तो वो देख के पता लगे order with respect to NO, that's order 2. ठीक है, because you doubled and it quadrupled. और O2 का देख लो कि if I want to investigate O2, then I would have to keep the other variable constant. I just want to investigate rate with O2, so NO has to be kept constant. So in this case, I'm going to investigate this experiment and this experiment. The NO is constant. Rate increases 1.5 times. 75 divided by 50, that's 1.5. So the concentration of O2 increases 1.5 times. The rate of the reaction also increases 1.5 times. So the 3 divided by 2, so that is 1.5 times. So uska matlab it's directly proportional. Like if it increases 1.5 times, the rate also increases 1.5 times. So that's obviously order 1. So here's another one. I need to figure out the order with respect to each one of them. So if I want to find the order with respect to this, I need to keep the other ones constant. So which experiments should I use to investigate the rate or order of this one? इसके लिए कौन सा वाला होगा? It's going to be which one would you use? 2 and 4. 0.05, this is 0.05. 0.05, this is 0.05. By what factor does the concentration of the propanone increase? 25 divided by 20. What do you get for 25 divided by 20? That's 1.25 times. By what ratio does the rate increase? That's approximately 1.5 times. 1.042 divided by 0.833. The EV 1 point, it's coming out to be 1.25, right? So that's order 1. That if you compare experiments number 2 and 4, so both of them they increase 1 point, so it's order 1. They're just looking for an order, they're not looking for an explanation. So what about hydrogen ions? Now, which experiments should we compare for hydrogen ions? For hydrogen ions, I guess it's is it 1 and 3 that I should compare? Okay, this remains constant. Now, in the case of hydrogen ions, I just want to vary hydrogen ions. I want to keep the other ones constant. So if I compare 1 and 3, is 6 and 5 pe aa gaya. The other ones are constant. 0.06, this is 0.02, this is also 0.02. And I'm going to try and figure out how the rate changes. So you can clearly see 60 say its concentration decreases to 0.050, right? So you can clearly see that there is no change happening. What's our order with respect to H plus 1? कौन सा बनेगा इस केस में order? it's going to be zero order. ठीक है, that's order zero. And which experiments did we compare? We compared 1 and 3. That's the last one, cyanide ions. This one. Which experiments will I compare? Achha, for cyanide ions, I'm going to compare. Should I compare maybe 3 and 4? No, I can't do that. I just want CNNs to change. What about 2 and 3? That's 2 and 3. If you look at 2 and 3, so you're going to compare 2 and 3. So if you compare 2 and 3, the concentration increases by how much? 60 divided by 50. What do you get for 60 divided by 50? That's 1.2, right? So 2 and 3, all the others are constant. This is 0.2, this is 0.2, this is 0.05, this is 0.05. This increases by 1.2. By what amount does the rate increase? That's I think that's 1.2 as well. That's 1 divided by 0.833. So that is approximately 1.2. So that's order 1 as well. So my rate equation is that it's dependent on the, I'm going to put a K. So it's dependent on my first reactant, CH3. Order 1. It's not dependent on my second reactant. H plus 1 is 0 order. And it's also dependent on my third one, cyanide ions. It's order 1 with respect to that as well. Okay, is this clear? तो ठीक है, इस एक में लास्ट कर लेता हूँ कि what you एक में लास्ट कर लेता हूँ कि I told you about mechanisms that anything that's involved in the fast step, it will have 0 order. Anything involved in the slow step, that's going to have order 1 or order 2. So ये दोनों जो है ना, they're involved in the slow step. This one, the rate of the reaction does not depend on it. So it depends on it's probably in the fast step. These two will be, these two will be in the slow step. So which one is the proper mechanism for this one, for this reaction? It's going to be mechanism B, because the first two will be involved in the slow step, so that the rate of the reaction depends on these two, and the H plus 1 will be involved in the fast step. तो उसने कहा था खुद ही लेबल करो, ठीक है? So these two will be in the slow step. You increase the concentration of these two, the rate of the reaction will increase. लेकिन जो H plus 1 है ना, that is in the fast step, and so that's how you'll figure out which mechanism corresponds to this one. ये वाला clear part, this one. ये हमने पहले किया था कि you're going to relate it. Anything that's got 1 order, that's in the fast step, so he's in the slow step. Anything that's got 0 order, that's involved in the fast step, because the rate of the reaction does not depend on this. So ठीक है, ये कल करते हैं, next time करते हैं और questions, ठीक है इसके. We're pretty much done with the topic. We'll just do the remaining bits and pieces, and we'll try and do more past paper questions as well. Okay. So, okay, everyone. Of this.